Welcome in this lecture of environmental science. This is series of live lectures. As you are aware, because of this COVID-19, there is lockdown in Mumbai. We are not able to go outside our home, and so we are starting out this series that is environmental science live lectures. So we are now focusing on next part, that is nuclear energy. In previous lecture only, we discussed about this nuclear energy. Just, yeah. In previous lecture only, we discussed about nuclear energy. Now here, I am revising some part, and then we are going into detail, the plus and minus of this nuclear energy. So first thing, uh, when we are talking about this nuclear energy, usually we are using uranium-235 as a fissile material. That means a fuel. Now this uranium-235 is undergoing splitting, that is nuclear fission reaction. And we are getting barium and krypton and 2 to 3 atoms of, 2 to 3 slow moving neutrons, which carries further the reaction that is called a chain reaction. Now, here we are focusing again on this particular incident. Say, this is not very simple reaction that uranium-235 is undergoing breakdown and it is forming barium, krypton and 3 neutron. No, it is actually barium and krypton are major products. But apart from barium and krypton, various other nuclei, they are also formed. Whatever the barium, krypton or whatever the other series of nuclei means here atom, they are formed, they are radioactive. It is not that uranium is heavy, therefore it's radioactive. Yeah, but there is artificial radioactivity also. And now we are aware that even lighter elements, if they are synthetically produced, they may be radioactive. Say for example, sodium. You are aware that sodium 23. Say when I am saying 23, it's mass number. So sodium 23 is regular sodium, which is non-radioactive. But sodium 24 is radioactive. So like that, various elements, they are synthetically produced, then they may be radioactive, maybe. Certain elements like promethium is radioactive only. No doubt it is not having atomic number greater than 82, but still they are radioactive. So like that, various radioactive elements are formed in this series, and then they are having very high half-life period. So what happened actually? This disintegration means one nucleus is converted into another nucleus. Like that, there is set of atom. Then the rate of reaction is proportional to initial mass. That means suppose I am having 100 atoms, then after a certain time they will be converted to 50. Then after that same time from 50 to 25. Then from 25 to 12.5, like that the series is going on. We are calling this as disintegration of that nuclei. That what period we are saying, that is called as half-life period. Now half-life period of nuclear, whatever the nuclei form, they may be smaller or they may be higher. They can persist over several thousands of years. Even some elements can persist till lakhs of years also. So this is the first thing. Whatever the series of elements are formed, so it is not only barium and krypton are formed. Apart from that, various other elements are also formed. Then the second important thing, that slow moving neutrons are released. They are hitting out another uranium-235 and we are controlling out that with use of boron and cadmium rods. Now here in this reactor, we are using usually molten sodium, that is to carry out heat. You are aware that sodium is alkali metal. Metals are good conductor of heat and electricity, but usually metals are having very high melting point. whereas sodium is having very low melting point. Say very low means not below zero, but it melts around 80 degrees Celsius. So as we are heating out sodium, prior to boiling point of water only sodium start melting out. And then that molten sodium is used in reactor. That carries heat from reactor to the boiler. There is coil in which sodium is circulated and then water is heated. That boiled water that generate obviously vapor, and very high pressure vapors are generated because of high temperature in this nuclear reactor. Now, advantages, let us go first. We are calling this as clean source of energy. Say for example, when you are using 1 gram uranium-235, it is giving heat that is equivalent to burning out 100 metric ton of anthracite. You are aware that anthracite means one of the purest form of coal. So when we are burning out 100 metric ton, you are aware that 1 metric ton, that means 1000 kilogram. So 1000 into 100, that is we are getting 1 lakh. So when 1 lakh 1 lakh kilogram we are burning out coal, then whatever the heat is generated, that heat we can obtain just by getting destroyed 1 gram of uranium-235. And that's why it appears very clean process. Whereas when you burn this 100 metric ton of coal, it will generate tremendous amount of carbon dioxide, carbon monoxide, sulfur dioxide, various nitrogen oxides and all that. And that's why we are saying this is very clean process. The second important thing that we can control out this reactor, and we are getting this energy at much more cheaper rate than what we are obtaining from thermal electricity. Yes, this is also true to some extent, but the disadvantages now, for only this much of plus point, what we are facing disadvantage of this nuclear power reactor that we must consider. The first thing, we are using fuel that is uranium-235. Suppose we are using that is we are calling as enriched uranium. What is the process of enrichment of uranium? It requires tremendous energy. So it is not that when we are using 1 gram uranium, yes, it's true that when we are using 1 gram uranium, we are getting tremendous energy. But to obtain that 1 gram uranium-235, what energy we are using, that we are not accounting here. That is the first drawback. The second thing, that whatever the byproducts are formed, that barium, krypton and so many other nuclei, they can persist for several lakh years. And right now we don't have any method to dispose them of. So we are categorizing them under nuclear waste. And then whatever the waste world that they are using that method, that similar method we are using. We are using this thick lead container. We are taking out that all your radioactive product in that thick lead container, and we have to bury them in the desert, particularly making cement chamber. We have to bury these lead box over there. They can be there for several lakh years right now. All right, but you are aware that just in previous lecture only we discussed that where is there desert. Once upon a time there was a Greenland, when the forest that get buried out inside, and like that theory we discussed. So what is the guarantee that after 1 lakh year this desert will be desert only? Maybe possible that can be converted into Greenland again, and then obviously water will flow from surface which will penetrate inside. Lead is not that reactive, but ultimately over thousands of years that boxes can be opened out, and then that material can be spread. So this is the biggest problem of our environment. Let me clarify here. Cassini Eugene is name of space mission sent to study out Saturn and its satellites also. When they observed towards Titan, they observed that the situation on that satellite of Saturn is very, very similar to the earlier stages of Earth. They observe their methane gas, they observe their ammonia gas, they suspect that water existence is also there. And then what was the earlier idea? That this Casino-Eugene mission, it was fitted with nuclear reactor. And the end of mission was supposed to be this way, that they were going to collide that on satellite of that Saturn. But ultimately they cancel out the plan. They means NASA. They cancel out the plan because this is somewhat similar situation observed in Stanley Miller's experiment. What Stanley Miller suspected out at beginning of life on Earth. So similar situation is there. We are taking that much care. Then just imagine on Earth how many reactors are there, nuclear reactors. Right now in India, there are so many nuclear reactors. And what we are producing out waste material, that we have to take into account. That is the first objection. The second objection for this process, that no doubt this is the cheaper source of energy. But in order to make it secure, we require tremendous security systems. And for that purpose, again, it's costly to get all these meters. And then we can check out that no leakage is there. And still, certain natural calamities are there. Now, what are given in book, that is Fukushima disaster that happened in Japan. You are aware of that because of tsunami that hits that uh, Fukushima uh, nuclear reactor. And then what measures? There was tremendous tension for Japan. First, because of this natural calamity, and second, because of this nuclear reactor was there. Now, similarly, another incident was reported in very old days, that is in the 20th century latter part, that is Chernobyl disaster. So in at that time USSR, there is a place that is called as Chernobyl, where the nuclear power plant was there and some disaster was there because USSR was having communist power at that time and dictatorship. What the incident happened, that was not came out immediately, but after few days, the French people, because France is having tremendous amount of nuclear power project and they are having these security systems, they detected that radiations are coming out from their eastern side, that means from Russian side. And then Russia declared that yes, there was some disaster and radiations came out. So these type of disasters may be there. I'm not saying they are there. What I'm saying, they may be there. So these type of disasters are again another threat for this nuclear power plant. So these two important things. The third is not that important, but we have to consider that once we started out nuclear power project, then we can't stop it immediately. That means, suppose we have having requirement at daytime, high requirement is there at daytime, then we are withdrawing that nuclear power. But at end of the day, suppose the requirement of electricity is less, so we can stop that reactor. So answer is no. Once it is started, we have to make it continue, whether requirement is there or not. That means we are now producing electricity, but that is not required during particularly night time. Again, at daytime, we are in requirement of that energy and we can't stop this reactor. So alternative methods we have to use. That's why I say it is not that important, but important that, for example, certain Haidle electricity projects are there. Water is stored at high altitude. It is taken down the dam. Whatever the potential energy of water, that is converted into kinetic energy and it is converted into electrical energy. That water is going in the river. But in certain projects, they are stopping that water. During daytime, they are using these generators to produce electricity. At night time, whatever the nuclear energy is produced, that nuclear energy they are utilizing to pull down that water again into the dam. So we are not wasting out electricity. Whatever the electricity is there, that is used to pull down that water, and then it is going. a request is there for students that when you are putting out any message, that can distract me because I am alone handling out this. So if any important thing is there, then only put down the message. Thanks. Continue observing. And if any problem is there that you are not able to hear or some background noise is there like that, something is there, then obviously put the message. I will listen to that. Let us start. So when electricity is generated this way, we can't stop. So in this type of project, we are taking Haidle electricity project along with this, and then we are managing these things. So this is another important incident, problem by using nuclear energy. But why we are using it? Because our energy requirements are very high. Hydel electricity, according to me, if you are asking personally, then I may suggest that hydel electricity is the best electricity. But the thing is that everywhere we can't generate hydel electricity. In India, there are many situations, many locations where we can produce hydel electricity. It's very nice thing that we can produce, but that electricity is not able to fulfill our all the requirement, all the need of energy all the time, and therefore we have to depend on another sources like thermal power station is there, then hydel electricity, tidal electricity, wind electricity, everything, and solar obviously. So we are now discussing about this nuclear power project. Now from nuclear, just let me clarify the location of that Chernobyl plant that is there uh, right now in Ukraine. In old day, it was part of USSR because when we were in the schools, we observed this incident live in the news. So that time it was considered as USSR. So today it is in Ukraine. Now we are going to discuss the hydel electricity. So we just discussed about nuclear electricity, then we are switching over to hydel electricity. But prior to that, I must explain the principle of generator. All right. So first we are getting discussing in the physics. This is actually part, but right now I can't draw anything. So I'm just explaining. You have to imagine in front of you two horseshoe-shaped magnet. Suppose this is one cylindrical horseshoe shape, another. Like that, we have to keep. Inside that, there is a soft iron rod. Soft iron means pure iron. So that soft iron rod, don't consider that we can bend easily, that's why it is soft. No, it is called a soft iron, which is having winding of copper wire. And then that rod is moved, rotated in that magnetic flux. If you are mechanically rotating out that rod, then electricity is generated. If we are supplying electricity, then automatically rod will start. So two way. Suppose I am using electricity to move that rod, then we have to call it as a motor, electrical motor. If that rod is moved mechanically, then electricity is generated, we are saying it's as dynamo. So this way we are having the basic principle of dynamo. So anyway, what is my thing? That I must move that rod. That rotation of rod is important. That rod is attached to huge wheel, uh, depending upon the requirement. Say for example, in case of your bicycle, if you want to fit this, then obviously that wheel size is small. But when hydel power plants are there, huge wheels are there. I visited one power plant. They told me that the wheel, that means that turbine is having mass 9 metric ton. That means 9,000 kg was mass. It looks like tire of tractor. And then water is released out from one end of that turbine. So turbine start moving with very high speed. And then obviously that there is change in magnetic flux and we are getting electricity. This way electricity is generated. To rotate that turbine, suppose we are using running water as a source, we are calling it as hydel electricity project. If to rotate that turbine, we are using pressurized water vapors, Then if that water is pressurized, water vapors are pressurized by heating out coal, burning out coal or naphtha or something like that, then we are calling it as thermal electricity. But if we are using uh, nuclear energy to heat that water, then we are calling it as nuclear energy. So like that, we can use. Now you are aware, suppose that turbine is moved because of wind. So huge windmills are there. These windmills are attached to this dynamo. Then windmills are rotating out. That blades are rotating out, and that's why turbine is rotating out. Then we are calling it as uh, wind energy. So like that, things are there. Now we are switching over to part that is Haidle electricity or Haidle energy. Why I call Haidle energy is best source? Reason number one, uh, no greenhouse gases are not at all polluting, and anyway water is flowing out. We are utilizing that flow of water. So how these plants are there? Uh, at high altitude, dam is constructed, water is stored in that dam. Then with pipes, that water is taken down and then it is released on turbine. Turbine start rotating and we are getting electricity. That water is released in river. So that water is not at all going to get waste. Many people are having some misconcept, like we are removing out cream from milk. So same way electricity is removed from water. So no, there is no concept that electricity is removed from water. It is present in form of cream in water and we are taking out. No, it is there. We are using potential energy, that is because of water is at high altitude. It will flow down. That means we are converting out that energy into kinetic energy. By using that, we are moving out turbine and then electricity generated. Clear? So this is Haidle power plant. Let me take specific study. Uh, in Maharashtra, there is place that is called as Koyna Dam, where this Haidle electricity project is there. In Satara district, the dam is constructed that is called as Koyna Dam. Those who are students of history or those who have learned out history, they are aware that when Afzal Khan arrived in the area, Shivaji Maharaj defeated him and his army was defeated completely. That valley we are calling as Zawli Valley. So entire Zawli Valley that is having this Koyna river. So in that forest only they constructed a dam. And tremendous water storage is there. Approximately altitude more than 600 meter. That dam is there. That is on the plateau region of Maharashtra. Then there is Western Ghat, and at downside, that means coastal side, there is a place that is called as Pofri in Ratnagiri district. Water is taken from Koyna Dam through pipe. The tunnels are there, and then it is taken down to Pofri, where turbines are moved and electricity is produced. So this is Haidle electricity. Now Himalaya is the most ideal position, ideal thing, so that we can generate tremendous amount of electricity from Himalaya. If you observe, there are many plateaus, many plains, many ravines. Tremendous amount of water is available in Himalaya. And so if you are exploiting out these all the thing, then Himalaya is actually very good source for Haidle electricity project. In Maharashtra, the situation is not that fortunate, not that good, because one side there is entire plateau, other side there is coastal plain, and in between that Sahyadri mountain is there. To the north side of Maharashtra there is Satpura range, but still, according to our record, Maharashtra is able to harvest out this hydel energy to very great extent. Whatever the limited sources, but they exploited it to very great extent, and almost everywhere in Sahyadri mountain ranges, the smaller, bigger, every size of dams are constructed. Now, disadvantage of this hydel electricity project. Number one, obvious risk factors. that in nuclear energy, if we are discussing risk factor, then here also we have to consider risk factor. The earthquake is the biggest risk factor. Because of heavier earthquake, can dam wall get cracked? And then just imagine the disaster followed by that. That is the biggest problem. It is not hypothetical, this happened. Again, the what dam we consider, that is Koyna Dam, there only this disaster happened. In 1967, after finishing of this project, there was huge earthquake in the area. Actually, Koyna Dam is there on the shield part of Maharashtra, that is called as Deccan Shield area. Basalt cap is there. And it was considered as the area, shield areas are opaque for earthquake. And still, tremendous massive earthquake was observed in the region of Koyna Dam only. The Koyna Nagar was almost all, at that time, many buildings, whatever the constructions were there, they were destroyed out because of this earthquake. Now, dam wall was fortified once again. So this is the disastrous part. If such type of disaster happen, then imagine the situation. You are aware that in Himalaya right now, just I explained that it is ideal position, but Himalaya is on junction of tectonic plate, where maximum earthquakes are happening out. And that's why when we have to construct that dam wall, we have to construct, obviously it is very strong, but apart from that, we have to consider the risk factor. Anyway, in case of Himalaya, these valleys are very, very deep, and then it can protect. If at all there is disaster, then can be protected to certain level. Say for example, in case of Bhakra Nangal, after the Bhakra Dam, there is Nangal Dam wall. So like that something we can do. But anyway, this is the factor we have to consider. The second important thing, that is it depends on rainfall. If rainfall is not sufficient, then we can't use this hydel electricity. So whenever in monsoon like climate is there, we can use it again and again. But again we have to wait till next rainfall is there. So this is the another problem in use of hydel electricity. The third important thing that we have to consider, that if there is theory actually, that why in case of huge dams these problems are there. So we are having the theory that because of very high pressure, water starts penetrating out. That penetrates in the lower strata of earth crust where very high temperature is there. And then the situation is something like pressure cooker. And then as vessel of pressure cooker moves, similarly that the earth crust upper strata start moving. Like that one theory is there. It is not proved, but they say that this is the expected theory, that why in case of these huge dams these earthquake problems are there. But otherwise, pollution wise there is no question of pollution. Security wise there is no much of the security is required. Once dam constructed is very good, and then whatever the tunnels, they should be well protected, because the water flowing through that tunnel is with very, very high speed. A massive amount of water is flowing through that, and that's why we have to take care. So these are things about hydel electricity. Whatever the more safer way, that is the wind electricity. But the question is that whether everywhere this type of windmills are there, then can we alter the source uh, or the cycle of nature? Now, I observed that to the Sahyadri range or Western Ghat, many places they are having windmills. Huge windmills are there. The blades they are moving out because of that turbine that start moving and electricity generated. It is non-polluting, not producing any greenhouse gas. Even there is no risk of earthquake and all that. But ultimately, it is the energy of wind we are altering out. So with the efficiency wind is flowing, at certain level we are going to resist that. Only that much the obstacle. Otherwise, wind energy is very good source of electricity. But thing is that again, what the energy generated is comparatively less energy. What intensity we require, that intensity is not fulfilled in case of this wind energy. So many windmills we have to construct. The initial costing of this windmill is much more higher. So windmill project is also expensive project. So those who can invest out in this project, they can get long-term benefit. So this is the another source of energy we discuss here, that is windmill. So today I am ending out this lecture over here. Thanks for observing this lecture. After this video, I'm getting ending out. We are starting Marathi lectures on the same background, on live background only. We are starting out Marathi lectures. So after ending out this lecture, we are starting out that. So those who are able to understand Marathi, they can observe that where we are starting out national freedom struggle. Thanks for observing. Let us meet tomorrow at same time.